Welcome to Brain Vision.
I believe this is the picture that you want in your problem, associated with your problem. You have three equal capacitors hooked in parallel. They have the same potential across them, so that's parallel. And they want to know what is the total charge going to throw through the ammeter. So let's think about a current I flowing through there. And we know that and I'm leaving I1, 2, and 3 for a moment just to be able to talk about things. We know that current, when we're talking about parallel circuits, you get three different currents in general. I is equal to I1 plus I2 plus I3. Now, I1 will bring a certain amount of Q, or charge. It'll bring Q1 to the capacitor. I2 will bring Q2. I3 will bring Q3. So, in the end, this would indicate Q total, however much charge passes through the ammeter, is going to be Q1 plus Q2 plus Q3. And we know that C is the same, V is the same, so each one of these is the same thing. So this is just going to be 3 times Q. And we know that for any capacitor, Q is equal to C, the capacitance, times the voltage, 3 CV. And so this turns out to be, with your numbers, 3 times 25.0 times 10 to the minus 6 farads times 4,200 volts. And this works out to be 0.315 coulombs. Again, it's just recognizing the parallel nature and what's happening to each one. If you were talking about in series, then you just have a single current coming in, and they all you'd have only the one value on the first capacitor. That's all that flowed. In this case, it's different. This is parallel. So knowing that the total or the equivalent is C1 plus C2 plus C3, which in this case is just 3C, that comes about from this idea that the charge is a summation. That's where this comes from. And that, I think, answers your question.